So there's a reason that your geometry teacher never let you use angle side side or side side angle, as we're going to refer to it here. Not just because it made a bad word, but because it makes an ambiguous case. So if you look at this potential triangle I have here, we know a side little a equals 2, side b is 4.07, and the angle A is 44.2. But as you can see, this does not make a triangle. It's not long enough. So it could make 0 triangles, or it could be anywhere along this line, and it could make 1 triangle. Or if you notice, if we're able to drag little a here, it could equal 3 and make a triangle this size, or we could scoot it on the inside and it could equal 3 also. Let me scoot it a little bit more. It could equal 3 on the inside also. So there are 2 different versions of a triangle with side length of 3. It could be either out here, or it could be on the inside here. So no matter which way you slice it, you could have more than 1 triangle. So the easiest way to explain this is, when you do your law of sines, if you get an error in your calculator, then you have 0 triangles. That means the side is too short. If you do get an answer, that means you're guaranteed to have 1 triangle, but you need to try and see if you get 2 triangles. So you take your angle that you get and subtract it from 180. So if you get another positive answer and you add it together with your given angle, and if it's not more than 180, then you have 2 possible triangles. If you subtract and you get a negative, then, or if you get a positive but it exceeds 180, then you only have 1 triangle. So let's look at a couple examples here. On this first one, we have triangle ABC again, and we're going to be given that C is 200, A is 125, and angle A is 110 degrees. So if we set this up, we'd have 125 over the sine of 110, and that should equal little b over the sine of b, which should equal little c, which is 200, over the sine of c. So if we take these outer 2 and cross multiply them, we would get 200 sine 110 equals 125 sine of c. And so when you divide the left-hand side by 125, you get 1.50. But you know from doing the unit circle, we cannot take the inverse of sine if it's a number bigger than 1. So therefore, this one is not a triangle. There are 0 triangles possible. So let's try one that works out a little better here. If we do A, B, and C again, if we know that angle B is 31 degrees, little c is 46, and b is 29. Again, we can set up our proportions here. So we'd have little a over the sine of a. And again, you don't always have to go in this order. The key is that you just do the corresponding side and angle together. So little c would be 46 over sine c. So obviously we have to solve these last 2 first. And so we'll have 29 sine c equals 46 sine 31. So we get that the sine of c equals 0.8169, which is good. So that means that we are going to get an answer out of this one. And so we'll get that angle c equals 54.8 degrees. So it could be that, or if you take 180 minus 54.8, we would get 125.2. So those are the 2 possibilities for angle C. So if you want to draw those out, basically like the triangle that we have there. So we'd have a 31-degree angle, 46, 29, and C could be 54.8. Or it could be an obtuse triangle with 81 or 31, 125.2, and this side being 46, and the bottom being 29. So we're not sure which version we're working with here, so we need to try it two different ways. So set up both those ways. We can subtract from 180, and we get that A is 94.2 in this triangle, or it'd be 23.8 in this triangle. So we'll proceed from there. So it's either going to be A over the sine of 94.2 equals 29 over the sine of 31. Again, you could use, now that we know angle C, but if you mess up angle C, you've messed up other stuff, so you might as well go back to the beginning here. So 29 sine 94.2 equals A sine 31. So A is 56.2. Or we could have A over the sine of 23.8 equals 29 sine of 31. And so we'll have 29 sine 23.8 equals A sine 31. So the A could equal 22.7. And so again, you could check and be sure. So like your biggest angle in the first triangle we drew is the 94.2, and 56 is the biggest side. 23 is the smallest over here, and it is the smallest side. So both of those versions are correct. So that's a possibility where you could have two triangles.